Okie dokie. We are on the last one. Well, of 2017. Woo! Are you getting tired of listening to me? I would be if I were you. All right, 2017, number 6. So now we're going to be pretty derivative heavy on this one. So we got a whole lot of stuff going on. Let f be this function. Oh, how do I? Oh, I got to open this in Cami. It's going to stop. All right, hold on. Boop, boop, boop. Sorry, I hope you're fast forwarding this little part. Okay. Here we go. So they're giving us a whole lot of information. We've got a graph of H. Oh my gosh, just stop. I don't want information. Okay, I've got a graph of H. I've got information about G and G prime. I'm told that F is this function, so there's a whole lot going on. So blah, blah, blah. Let's start with A. Find the slope of the line tangent to the graph of F at x equals pi. Okay, totally can do this. So this would be a no calculator problem. If this was a test for me, again, you have a calculator. It's hard to have you not use it if you're home, but you would need to show me that you took the derivative of F. So you can't just plug in pi and get the answer. The answer is going to be -1. But if you just put -1, you are not getting the point. You have to show the derivative as well. So let's go do that derivative over here. So the derivative of f is going to be the derivative of cosine is negative sine of 2x times 2 plus the derivative of e to the sine x is e to the sine x times the derivative of sine x, which is cosine x. To find f prime of pi, I'm plugging pi into everything. Oh, Connor, this is my favorite part where I always mess up. Let's see if I can do it without messing up. Plug pi in. So we have the sine of 2 pi. The sine of 2 pi, I think, is 0. So this whole term is going to be 0 plus e to the sine of x. So don't get confused and think that that's going to be 0. It's not. This is going to be e to the 0 times the cosine of pi, which is -1. So e to the 0 is 1 times -1 is -1. And that is correct. That is worth 2 points. So 1 point for showing, I don't know how it's split up. The derivatives, it would depend where you might have made a mistake. Split up the points. Okay, let k, oh my gosh, we're going to give us another function. Awesome. Let k be the function defined by this. Find k prime of pi. So we'll take the derivative of k. So k prime, we're going to use chain rule, is going to be the derivative of h with respect to what's inside times the derivative of what's inside. So this is chain rule, right? I was just reading something the other day that I meant to tell you that I was reading this teacher explains chain rule like eating a peanut M&M, that you like eat the outside with respect to the peanut and then you might eat the peanut. I don't know. It's like one way you could eat a peanut M&M. And someone was like, kept messing up chain rule. And the kid in the class is like, don't eat the peanut first, you idiot. It's not really a funny story, but it made me think about that. Okay. So here's the derivative of k. Now we got to plug in pi. So k prime of pi is going to be h prime of f of pi times the derivative of f at pi. So h prime of f of pi, so we're going to have to go find out what is f of pi. So I'm going to have to plug pi into f. So go over here. So the cosine of 2 pi, that's 1. E to the sine of pi is e to the 0. So we have 2. So this is 2. F prime of pi we already got, right? In part A, we already know this is -1. So h prime of 2. Okay, so now we have to go to the graph of h and see what the derivative of h is at 2. So here's the graph of h. Here's 2. The answer is not this y value, it's what's the derivative there. So the derivative here, we are down 1 over 3. So the slope of this part is negative 1/3. So I'm going to have negative 1/3 times negative 1 gives me a total of 1/3. Let me check my answer. Yep, that is correct. And that part is also worth 2 points. All right, there's a lot going on there. If you followed, I hope that that made sense. Okay, let m be another function. Awesome. Okay, let m be the function defined by this. Now they're going to test you on product rule. Find m prime of 2. Okay, m prime of x equals, we're going to product rule this. So the first times the derivative of the second plus the second times the derivative of the first. So the derivative of g of negative 2x is going to be g prime of negative 2x times the derivative of what's inside, so times negative 2. You do get a point for that derivative. Hold on, I'm just looking to see if I messed anything up because I want to make sure I don't get anything wrong. Negative 2. Oops, it's negative 2. It's h of x. Okay, good. And now we got to plug in 2. So m prime of 2 is going to be g of negative 4, h prime of 2, plus h of 2 times g prime of 4, negative 4, times negative 2. Okay, so let's go figure out what these are. I'm going to be scrolling up and down. So g is all on the table. That's great. So g of negative 4 is 5. So this is 5. I'm just going to do this because I'm using the table. What's g prime of negative 4? I'm going to get that as well. G prime of negative 4 is negative 1. And now I got to get h and h prime of 2. And h is up here. So h of 2, I'm going to use the graph. So h of 2 is here. Well, how do we get that value? So how do I find out what h of 2 is? I can't see where I am here real easily, but I do know what the slope is. So I know since the slope is down 1 over 3, I'm moving down 1/3 every time. So h of 2 should be negative 2/3. And then h prime of 2, I already got up here, which was negative 1/3. Oops. Negative 1/3. All right, let's put this together and see if we get what they got. So we got negative 5/3 minus, put all this together, 4/3. So negative 9 over 3, or negative 3. Yay, that's their answer. Okay, that part was worth 3 points. There's a lot going on there. It looks like they give you 1 for the derivative of m, and then 1 for that final answer. Again, if this is the test next week, you got to show me all this work. All right, I want to see it all. I don't want to see just answers. All right, let's look at part D. Just give myself some space. Oh wait, I figured out how to do this. Hold on. There we go. Okay, part D. Is there a number c in the closed interval -5 to -3 such that g prime of c equals -4? Justify your answer. So this is either setting us up for Rolle's theorem, but if it was Rolle's theorem, it would say where g prime of c is 0. So I know it's not Rolle's theorem. I don't need to look and see, like, do I have the same y value at both of the endpoints? So the other thing that this could be setting me up for is mean value theorem. So let's see if mean value theorem is what they're trying to get me to do here. So the mean value theorem would say on this interval, first of all, is G continuous and differentiable? I have to probably make sure that they said that somewhere. Yeah, G is differentiable. So G is differentiable. Because they say justify your answer, if mean value theorem does work, I do need to say that. So G is differentiable. So let's see what the slope is between these two endpoints. So let's say if I have that x value of -3 and an x value of -5, let's find the y values that go with them and see what the slope is between them, because maybe the slope between them is -4. And if that's the case, then mean value theorem is what they're trying to get me to cite here. So -3 and -5 are x values. Let's go look at G and see if what those y values are. So -3 gives me a y value of 2. And -5 gives me a y value of 10. So let's see what the slope is between these 2 points. So if I'm writing this up as mean value theorem, I'm asking myself, what is G of -5 minus G of -3 over -5 minus -3? This is the slope formula for G. So let's see, 10 minus 2 over -5 minus -3. This, if I'm using mean value theorem, this slope should give me the derivative of G at some point C. So what does this slope give me? I have 8 over -5 plus 2, so -2, -4. Yep. So this means that the slope between these two endpoints is -4. The mean value theorem guarantees, therefore, that the derivative of G somewhere in this interval will also be -4, will be the same as the slope between the endpoints. That is mean value theorem. This is worth 2 points. To get the points, you need to show that you found the slope and that you cited the mean value theorem. To cite the mean value theorem, you also have to say that G is differentiable. So by mean value theorem, because G is differentiable, the slope between the endpoints is -4, which is therefore also the derivative of G somewhere in that interval. Okay, that wasn't too bad, hopefully.